Welcome again to OTRONICON! Awesome. Today I have the pleasure of welcoming Dr. Mike Ambinder. Dr. Ambinder is a senior experimental psychologist at BAL, which you guys all know, right? BAL's awesome! Yeah, Steve! Steve, okay, sorry. Stop. He is a graduate of the University of Illinois and Yale University and has worked on DOTA 2, Team Fortress 2, Portal 2, Left 4 Dead, Left 4 Dead 2, Counter-Strike Global Offensive, and Alien Swarm. Today he will discuss how advances in applied research, biofeedback, and virtual reality are expanding the frontiers of game design, and how game designers are looking forward to pushing the boundaries of what games can accomplish. Please join me in welcoming Dr. Mike Ambinder.
Can everybody hear me okay? Yeah. All right, great. So thank you for coming to the talk. My name is Mike Ambinder. I'm an experimental psychologist at BAL. So this is an example of me pretending to be a psychologist at BAL. That's our CEO, Gabe, lying on the couch. This is crazy. It's not actually what I do. I'm an experimental psychologist. My focus is on research, trying to understand the influences on behavior and how to apply them to game design. So really quickly, just kind of give you guys a review of the talk. I'm going to talk to you about, I guess, 3 avenues of inquiry that game designers are starting to follow to think about, I guess, pushing the boundaries of game design and where we can take it. And so talking about applying the scientific method, scientific processes, and scientific knowledge to game design, talking about biofeedback, and then ending with a discussion of virtual reality or VR. So this is an example of how we make games. If you played any of our games, if you like the way that we make games, this is it. It's a very straightforward process. If you start on the left, we come up with some game design, some piece of content that we want to test. It's a hypothesis about what players might like to do. And then we play test it. So we put it in front of people who are not us, people outside the company, and get their feedback. We take their feedback, and then we incorporate it and iterate and improve upon the design, and it's a cycle. And this is how we make games. If you are familiar with the notion of battle times, the notion that our games tend to take a long time to make, it's because of this process. It's because we're constantly iterating and improving or trying to improve the game based on feedback we get from people who are not us. The reason I drew it like a cycle is because I also wanted to show this picture, which you may have seen in 2nd grade. It's the scientific method. The notion of taking data and making predictions and designing experiments. For us, the experiments are our playtests, and then gathering data from the experiments, and then coming up with a new theory, a new game design, and something else to try. We use the scientific method, we apply it to game design, and it's by far the best methodology we have for creating knowledge. And there's no reason why it couldn't work in game design, and so we use it, and it tends to work very well for us. So that was more about the process of science, applying it to game design, but there's also a bunch of content, there's a bunch of knowledge in all disciplines of science that are really useful for game design. So I'm a psychologist. I'm going to talk about an example of psychology at the end, but you think about examples in biology, understanding how the visual system actually works. For VR and any kind of environment where people are processing visual stimuli, having an understanding of the biological processes underlying it can help us make better games, and we try and take advantage of that. With economics, we have a bunch of games that have in-game economies where you can buy virtual items, you can trade virtual items, you can sell virtual items. So we can do all kinds of interesting things inside of a game that you can't actually do in the real world. So we can do economic experiments that are not possible with real world economies, but we can also use economic knowledge from the real world and use that to help us design our economies and understand why people are doing what they're doing. With engineering, you can think about designing cities and city builder games, or building structures, taking advantage of mechanical engineering. There are games that take advantage of chemical and structural engineering. The notion that just having an understanding of how systems are designed is pretty powerful, and so we tend to take advantage of a lot of engineering knowledge when we're making our games. History is maybe more of a straightforward one. There are a whole bunch of really fascinating and sometimes exciting events that have happened over time, and being able to experience them inside of a game can be pretty powerful, and so we like to take advantage of that. Physics is maybe more straightforward. We have a lot of knowledge about the way the world works in our experiences, just kind of interacting in our environments. And so when you design games, it's really important that those expectations about how things interact coincide with what you experience in the real world. And so we try to design our games to take advantage of real-world physics and also to understand when we can violate those constraints and make things more exciting and more entertaining. And then the last topic I have up there is psychology, which I'm going to talk to you guys about. But the point of this slide is really just to, emphasize there's a whole bunch of knowledge out there that can inform how we make game design. And it's not just related to what you might think of as kind of more canonical game design techniques. It's just people have been investigating everything forever. And so taking advantage of what science has created to help us make better games is a really important part of our process and something we try and do as often as we can. So the last point I want to make about science is that applying knowledge from one domain to another is pretty powerful. It's pretty useful, and it's a pretty, fertile territory to explore. We're kind of just starting to think about ways we can take knowledge from psychology or sociology or economics or biology or engineering or whatever, and then apply it to the kind of content we create. I was interested in psychology and video games, and I ended up turning that into a career. Not a common thing, but I thought there was utility there. And so the notion of just taking, whatever disciplines you like and seeing if there is a way to create an intersection is a pretty powerful one. At least here I'm talking about applying, aspects from all ranks of science to game design, but the broader principle applies to whatever you're trying to do. Thinking of intersections is pretty useful, and so when we're trying to be creative, it's really hard to come up with original ideas. But if you can think about, if you can go look at other fields that are kind of seemingly unrelated to what you're doing, and say, hey, what are the cool ideas in those fields? Can they be applied to what we're doing? It's a pretty useful metric of creativity. Say, hey, instead of being, again, totally original thoughts are hard, but lots of thoughts you haven't thought of that other people have. So seeing where they intersect, where they interact, it's pretty valuable. And it's, again, something we try and do as best we can. So I'm going to talk about one specific example of applying knowledge from one seemingly unrelated or potentially unrelated domain to what we're doing in games. So there's a finding in psychology called cognitive dissonance. I'm not sure if you guys are familiar with it, but it's the notion that when you hold inconsistent or opposing thoughts in mind, discomfort arises. So an example of that might be you think you're a generous person, you happen to walk by a homeless person on the street, but you don't give them any money. So you think you're a generous person. In this one instance, you were not a generous person, and so dissonance can arise. This happens across a wide variety of things, and whatever kind of that there's some sort of attack or some sort of challenge to a belief we have about ourselves, we undergo cognitive dissonance. And so when that happens, we seek to resolve that dissonance by challenging or removing or altering one of those antagonistic thoughts. We want to try and change it. And so we can take advantage of this finding and maybe change behavior in our games. So this is an example of a sample chat log from one of our games, DOTA. It's a game where you have two teams of 5 players playing against each other. Sometimes they're not always nice to each other. If you're reading the text, you can see that in this case, constructive criticism is being offered, everybody's being nice. Oftentimes that's not the case. People can be aggressive, they can be abusive online. And so it'd be great to figure out a way to kind of reduce occurrences of chat where people who are playing against each other or playing with each other are not treating each other well. So you don't need to worry too much about the text on the screen, but if somebody in DOTA is not treating you well, you can click on their name and report them. Say they were being abusive in your communication channel, they were misusing their abilities, they were dying too often, and so forth. So it's a pretty nice metric of player behavior, essentially, in the game. So this is what we did. At the end of the game, every once in a while, we'd ask you a survey question. In this case, the survey here is teammate cooperation. Please rate the cooperation your teammates displayed in the last match, 1 to 5 stars. We can get useful data from this. We can find out how good our matchmaking is, what sorts of events in games make you think highly or not as highly of your teammates, and so forth. But I'll be honest with you guys, I asked this question, I really didn't care about the answers. I only asked it so I could ask the next one, which is your cooperation. Please rate the cooperation you displayed towards your teammates in the last match. So what happens here? As humans, we have a natural tendency to want to rate ourselves highly on whatever axis of comparison is most salient. So if you see this survey, you're going to want to say, yes, I was a good teammate. You want to say, yeah, I was a good teammate. If you know you weren't a good teammate, that's a conflicting thought. You will undergo cognitive dissonance, and you will seek to reduce or remove that dissonance. And so what happened, what we wanted to happen, was that people would see the survey, and then afterwards, they would modify their behavior and try and be nicer online so they could answer this question honestly and not undergo cognitive dissonance. And that's what we found. So I told you we had the report dialogue, and so after we did the survey, the only change we did was ask those two questions. 137,000 fewer reports per day across millions of players and millions of games, just because we asked two simple survey questions every once in a while. Right? It's a pretty cool application of a finding from psychology, cognitive dissonance, applying it to game design. So the takeaway from this section, right, is knowledge of seemingly unrelated domains, can and does effectively transfer across them. I'm a psychologist, so I'm always thinking about it from a psychological perspective, but the broader principle applies. Whatever discipline you tend to enjoy, there could be some pretty interesting intersections that happen. So. All right, so moving on to the next topic, biofeedback, and really what I'm referring to here is just the measurement of some sort of physiological signal. So heart rate, skin conductance is essentially, it's a measurement of physiological arousal, essentially how excited or agitated you are, and it's really a measure by placing two metal contacts on your skin and you're just measuring the electric current, and the actual pH content of your sweat will change depending on how excited you are. So there's skin conductance and facial expressions and eye movements, all kinds of things that give essentially insight into somebody's internal experience. Like, what are you feeling? Are you happy? Are you sad? Are you challenged? Are you feeling aggressive? Are you bored? All kinds of things. So the notion of biofeedback is simply this. You have some sort of physiological response starting at the top, and it's an input to some sort of system. In this case, it would be a game. And the game processes that input and creates a response. It changes something on screen, and then conveys that back to the player. And in turn, seeing what the game did, that's going to induce a new physiological response, and so you get a feedback loop. So this is what people mean when they say biofeedback. So why is this useful? So what can we do with biofeedback? So with current control schemes, so if you're playing a game like a mouse and a keyboard or a gamepad, what we're doing is we're mapping player intent to on-screen action. So if you press the X button, you're going to jump. If you move the right analog stick forward, you're going to move on screen. So it's simply saying, what does the player want to do given this restricted set of actions? And let's map that intent to some on-screen behavior. What we're lacking is insight into the internal experience. We don't know if you're happy or sad or challenged or frustrated, what you're going through. So with biofeedback, we can start to attack that problem. The hope is that we can get some accurate and reliable measurement of your internal state, and then use that to adapt the game. Use that to change the game. It's another axis of measurement that we don't currently have, right? Right now we just know if you want to jump or run fast or switch weapons. But we don't know if you're happy or sad while you're doing it. And if we did, we could do some interesting things. So the bottom axis, the x-axis, is just time, and then the y-axis is a measurement of arousal, the vertical axis. And so essentially you can see somebody's arousal level over time. I've annotated some of the spikes that you see. And so what we have now is, again, a real-time record of what players are going through while they're playing a level. And if you do this enough, with enough players on enough levels, you can start to build up a database of systematic responses, how people react to various things in game. And all of a sudden, we have much more insight into what things are valuable to players, what things make them more aroused or less aroused. And if you couple this with like a camera looking at facial expressions, you can tell if it's good arousal or negative arousal, or positive arousal or negative arousal. You can tell if they're feeling challenged or frustrated, happy or sad, energized or not. So all of a sudden, we have a new pathway of information that we didn't currently have access to. And with that, we can, in theory, do some pretty interesting things. We can have the game adapt dynamically to what you're feeling. If you're playing, you're doing a battle, and you're in a boss fight, and it's not challenging enough, we can detect that behind the scenes and change things. We can adapt conversations you have in a game to how you're feeling. If you're seeming frustrated, we can have help prompts come up and say, hey, looks like you're struggling, like here's this, right? It's just, with more information about what somebody is experiencing while they're playing our games, we should be able to make better games, more compelling games. So the takeaway I have here is, we experience games in a variety of ways, and then if we can better measure those ways, we can do some pretty interesting things. And here, at least with Biofeedback, I'm talking about better internal measurements of what somebody is going through. It's not just what they want to do with the game, it's how they're experiencing while they're playing the game. So the final topic we're going to talk about today is virtual reality, VR, is the common abbreviation. And really what we're talking about here are head-mounted displays, and I think there's some you can actually try. I think up on the floor too, I'm not sure. And I'll show you a picture in a second, but essentially a head-mounted display with a really wide field of view. And what happens here is that you get some separation from the outside world. If you're playing a game traditionally, you're sitting at your desk, you're sitting on the couch, you're watching or experiencing a game by looking at a screen. With VR, you're essentially inside the game, and it's a qualitatively different experience. And so, in the upper left is a picture of a headset in the center, and then the two controllers, and then there's two sensors as well. And the bottom right is somebody wearing the headset using the controllers. And again, I think you can see this for yourself. Down on floor two. But when you have a much wider field of view, when you're actually inside the game, so this is DOTA, again, one of our games, this is the VR view, you can have a lot more information. You can also create pretty interesting experiences where you're actually on the deck of a sunken ship and a giant whale is going by you. And so it's really hard to give people a picture of what VR is like by just looking at a screen. So I'm going to show you a quick video that attempts to kind of give you an idea of what it's like, but really, if you're interested in it, like the way to actually understand what's happening is to put on a headset and try. So we can try the second video.
He actually gets it!
Short taste, but the thing to take away here is that you're no longer distinct from the game. The game is happening around you. Things are happening behind you, or below you, or above you. You can interact with them as the way you would interact with things in the real world. And so, the takeaway I have here, right, is what happens when we actually put you inside the game, when that separation is removed. You do get a qualitatively different experience, right? Like the things are watching something on a screen versus having the screen surround you. There's people like to use the word immersive, and I guess it definitely comes into play here, where when you're inside the game and things are happening all around, that changes the kinds of experiences you can create. We're designing for flat screens at the moment, but all of a sudden we can design for a 360-degree environment, and like the potential there is pretty powerful. So basically, at the end of the talk, and again, I just chose three topics, three directions that I thought game design was headed towards, things that I thought were interesting, and it's understanding there's a whole bunch of knowledge out there we can apply to game design to make more informed and definitely more creative choices. If we can get insight into a player's internal experience, we can definitely design games that are more adaptive and reactive, and give us better insight into why our players like the things that they like, which is really powerful. And then finally with VR, just seeing what happens when you can actually inhabit the game, when you can live inside a game and what we can do. And so, I don't know where these things are going to take us, but I'm very curious to see where everything goes. And so thank you guys for listening to me. I very much appreciate it, and happy to answer any questions you have. Thank you.